Good afternoon, everyone. I'm Migi Laperal,
And I am Leocer
and we
Bularan.
are recent graduates from the Institute of Civil Engineering, UP Diliman. On behalf of our advisors, Assistant Professor Maria Brida Leadiola and Dr. Maria Antonia Tanchuling, we will be presenting our study titled An Assessment of Solid Waste Management Systems in 6 Cities in Metro Manila. Ecological solid waste management practices, as outlined by Republic Act 9003, are supposed to be the solution to the Philippines' growing waste problem. Given the importance of Metro Manila as the political and economic capital of the Philippines, its urban density and concentration of 22.98% of national solid waste generation in only 0.2% of national land area, accurate and accessible data are imperative to ensure sustainable urban growth and resilience by measuring performance and highlighting best practices. The questions we wanted to answer through this research are: how differently do LGUs practice ecological solid waste management? And what best practices in operations and policy can be learned from these LGUs? The study assessed how differently 6 LGUs in Metro Manila practice ecological solid waste management in terms of reduction, collection, diversion, and disposal systems in high, Quezon City and Manila, medium, Pasig and Marikina, and low, Navotas and San Juan, waste-generating LGUs. Performance was assessed using both qualitative and quantitative methods with 5 criteria per subsystem: effectivity, efficiency, cost-effectiveness, environmental appropriateness, and civic participation. By using a comparison-based benchmarking methodology, we were able to identify common problems and solutions and highlight the best practices of each LGU and what can be learned from each pairing. Information like city ordinances, problem areas, and recommended solutions were compared in each of the 4 subsystems. Financial data, when available, was compared with qualitative data for a quantitative analysis. Geospatial analysis was then used to assess the accessibility of waste recovery facilities, namely MRFs, or materials recovery facilities, junk shops, and recycling centers, based on an assumed walking distance of 200 meters, also mapped on an open source website. Lastly, a mass flow analysis was conducted in order to visualize and communicate the path of waste from consumer to final disposal, allowing more granular and technical policy and operations interventions. Findings in the waste diversion subsystem were then spatially mapped within each LGU and compared with population density. These findings were then uploaded to our website app platform hosted on MapContrib, which facilitates an open source, data-driven, and participatory platform which aggregates information and promotes transparency. Thus, the public can easily access information, foster accountability, showcase best practice, and become empowered key decision makers. Before we discuss our key findings, we would like to thank Miko Tamura, Faye Andal, and UPRI Youth Mappers for their guidance and support for our study.
Now I will discuss the key findings of our research. It is difficult to measure the waste reduction in the 6 LGUs, so we limit the assessment to a comparison between population growth rate and waste generation growth rate. From the graph, we can see that QC, Manila, and Navotas expect greater waste generation growth estimates per annum compared to its population growth, suggesting that reduction programs should be further improved. San Juan generally matched its population growth and waste generation growth rate, while medium waste generating cities, Marikina and Pasig, showed the most successful and confident waste minimization and reduction. Common to all LGUs are reduction programs which involve the following components: youth engagement through school clubs, house-to-house and homeowner association campaigns, annual inspection of business establishments necessary for permits, postering, flyering, and other public announcement programs, market and commercial establishment campaigns, especially with limits of use of certain packaging items, and proper training programs for barangay officials for effective monitoring and enforcement. Most LGUs have adequate reduction policies. Pasig City's Green City Vision, Manila City Tax Reduction Incentive Program can be seen as best practices that provide a solid platform to solid waste reduction and minimization. The fair rating of Navotas is largely due to their unsystematic approach to waste reduction in terms of policies and programs. For the collection assessment, the table shows the collection data gathered from the various solid waste management plans of the 6 LGUs. The cities of Marikina and Navotas collect waste using government vehicles. QC, Manila, Pasig, and San Juan have private contractors on a clean all package to handle waste collection. All cities implement a cell-based collection system where one cell is rationalized to fill one full collection vehicle. All cities targeted different levels of stakeholders, with programs suited to households using various platforms. Pasig City's collection programs are exemplary compared to other LGUs, and their inclusion of solid waste management programs for informal settlers and ambulant vendors. Manila was only given a fair assessment. This is largely due to a lack of discussion on SWM services serving its large urban poor settlements. Although Quezon City has a rationalized cell-based collection system, a fair rating was given due to oversights in waste transfer monitoring. Navotas and San Juan were given poor ratings because of unclear route rationalization. Overall, the cities of Marikina and Pasig can be seen as exemplary LGUs because of their effective reach, efficient use of assets, and citizen engagement in all socioeconomic levels, leading to cost-effective collections. Common diversion methods practiced in cities included composting and recycling. However, recycling was done in junk shops and MRFs merely as secondary sorting and recollection without any treatment mechanisms. Junk shops and MRFs are limited depending on industry partners that agree to buy particular types of waste. This makes the service unreliable and difficult to monitor as proper recycling is not truly practiced. In the graph, it can be seen that San Juan has the most aggressive diversion projection, while Marikina has the most conservative estimates among the 6 LGUs. Quezon City, Manila, Pasig, and San Juan are particularly optimistic about their capability to divert the entire biodegradable and recyclable waste flow by 2024, which may not be possible given the recyclable potential of some collected materials. Here shows that heat map developed for Quezon City, Manila City, and Marikina City. The yellow dots represent the facilities and the areas within 200 meters around it are shaded. According to the heat maps, the distribution of the MRFs and junk shops in Quezon City is very uneven. It can also be observed that there are too many highly populated areas that remain unserved by the registered MRFs and junk shops in Manila City compared to Quezon City. For Marikina City, the distribution of the facilities are too concentrated in a small area. The distribution of MRFs, junk shops, and composting facilities in Pasig City can be declared as evenly distributed and efficient since most of the areas with high population density are covered with clusters of SWM facilities. For the case of Navotas City, the concentration of diversion facilities are efficiently positioned within the areas where high population density is characteristic in the area. In summary, San Juan was given a poor rating because of the poor compliance to the minimum diversion rate prescribed by RA 9003. Marikina and Pasig were given good ratings for efficient diversion largely due to compliance of MRF serving each barangay. Although both Quezon City and Manila have the largest quantity of diversion facilities, the size of the LGU together with the urban density and waste generation profile exacerbates the need for efficient facilities, and many communities found to be underserved. For the disposal assessment, the common policies implemented in the 6 LGUs are the anti-littering policies adapted from MMDA guidelines and RA 9003 IRR. All LGUs dispose municipal waste in SLFs. However, no discussion, reports, or assessments were done on informal waste disposal prevalence according to the SWM plans. In summary, Manila and San Juan were given fair ratings due to high demand for street sweepers, suggesting that waste collection level of service may be lacking in some communities. Disposal efficiency and cost efficiency were low for San Juan largely due to the high SWM costs. A fair rating was given to QC's disposal due to transfer stations that have gone unmonitored without proper environmental clearances or inspections within the vicinity of the recently closed Payatas landfill. The figure shows that in the 6 LGUs, Quezon City has the most amount of generated waste. Although Marikina City has more waste generated than Pasig, Pasig City has larger disposal flow than Marikina City due to the significant difference of waste diversion between the two medium waste generators.
In terms of policy recommendations, given increasing consumption leading to a greater generation of waste, many governments have reviewed and concluded that placing the responsibility for post-consumer goods on producers can mitigate and manage waste. Extended producer responsibility is a policy where commercial and industrial producers are given a significant financial and physical responsibility for the treatment and disposal of post-consumer products. This responsibility could provide the necessary financial incentives to prevent waste generation at the source, promote better product design for the environment, and support waste recovery and recycling goals. This would also come hand in hand with waste collection fees for better levels of service, proper waste treatment, and investment in facilities and programs. San Juan stated in their 10-year plan that fees could reduce waste generation and increase household composting and recycling up to 30%. Navotas City is also in a position where most of its municipal ordinance frameworks are at their infancy, providing for a large potential for enacting ordinances and programs based on best practice learned from other LGUs. Ecological solid waste management aims to address growing threats to public health in the environment. However, its application in reality is often constrained by various physical, systemic, and technical boundaries. Despite the limitations presented by the data collected during the study period, the assessment methodology explored various waste subsystems using geospatial data and materials flow analysis, features the flexibility to be adjusted to suit any LGU solid waste management system. This model can further be developed as a decision support tool to better contextualize the management of facilities, systems, policies, and programs to better suit LGU resident needs while protecting public health and the environment. Overall, the result generated significant insight on comparing proper solid waste management practices on different levels of service, featuring various urban constraints while celebrating best practices that can be universally applied.